Tapestry-Cloud technology, a cloud-based system for OpenGL remote streaming graphics. Ascender's Tapestry-Cloud is a powerful and flexible technology to create bespoke client-side remote rendering systems, or command streams. As in a tapestry which is created with colored weft threads, so the wefts of Tapestry-Cloud create infinite patterns. With Tapestry-Cloud, each weft component modifies the behavior of a specific API. A very flexible, high-level descriptive language for wefts is used to modify the behavior of an API. The interactions between wefts offer design flexibility. In Phase 1 of our presentation, we run the unmodified standard OpenGL demo GL Mark II. Running this program in the Linux shell opens a graphical program as shown above. The host's GPU is used to render pixels to the host display. This is the typical invocation of an OpenGL ES2 program in Linux. In Phase 2, we run the previous program, but this time we intercept OpenGL APIs. This allows us to construct an OpenGL rendering stream. The wefts that control client and server rendering are enabled. The client you see above is running on the same computer as the server. The CPU and GPU are shared. The graphical output of the client is referred to as client-side rendering or command streaming. In Phase 3, we repeat the setup as in 1 and 2. But here, GL Draw Elements API's rendering is disabled only in the API's weft in the server. The server's graphical results are now missing GL Draw Elements renderings from the tapestry. On the client side, the remote OpenGL rendering stream is unchanged. Thus, the client's graphical output is identical to Phase 2. The weft that controls the client's GL Draw Elements renderings remains unchanged. In Phase 4, the setup remains the same as Phase 3, with one difference. The GL Draw Arrays APIs has also been disabled in the corresponding weft in the server's rendering tapestry. The client's graphical output and GPU usage are unchanged. The server's GPU usage is 0. This is an example of a cloud-based client-side rendering system created by 2 minor weft revisions. We now show client-side rendering in the cloud. The cloud server is located in Amsterdam, 70 millisecond round trip from the client in Tel Aviv. The remote rendering stream is transmitted to the client from the server. The client receives the rendering stream from the server and renders remote graphics. The remote client is synced to vBlank, which has a frequency of 60 frames per second. This demo streams 5 short OpenGL ES self-contained benchmarks that demonstrate a variety of techniques for programming three-dimensional graphics. The first 4 are taken from the GL Mark II benchmark suite, and the last is the well-known GL Gears demo. The server sends the identical rendering stream as in the previous phase. Now, the sync to vBlank is lifted, and rendering is unconstrained by the 60 frames per second limit. A comparison of the rendering rates shows that the frames per second in the unconstrained case is greater by a factor of 5.8. This gives an indication of Tapestry-Cloud's unexploited potential for client-side rendering. The flexible and intricate wefts of Tapestry-Cloud adapt to different versions of OpenGL. These powerful wefts can add new APIs to both server and client, as well as modify and debug server and client. Single, multi, or broadcast remote streaming protocols are allowed. High compression is attained by caching server resources. We have completed a proof of concept for WebGL on both clients and servers. We have also completed a proof of concept for remote surface renderer for Android, remote composition for multiple remote surfaces, and remote input that is flexible and has low latency. Presently, the proof of concept in progress is for Android 12 server client with Cuttlefish for containerization. x86 and ARM clients and servers are supported. Clients and servers may be of different architectures. Docker, LXC containers, and other containerization models are supported. Tapestry-Cloud may be run on public, private, and hybrid clouds. To maximize and fully exploit the possibilities Tapestry-Cloud has to offer, source code is included in licensing agreements. To discuss your company's application for command stream or client-side rendering, please contact us.